Hey adapters, I'm Doug Parsons. I'm a partner at Simpatico Studios, where we live stream conversations about complex business and social challenges with professionals like yourself who are working on the same issues. Our shows are live streamed in front of a global audience of your professional peers on simpatico.tv. I'm building a new type of online community for professionals like yourself on the Climate Adaptation channel. If you're a regular listener of my America Adapts podcast, I think you'll find that we're taking our conversations about important problems, policies, and solutions to the next level here. And if you're interested in being a guest, we'd love to hear from you. And now join us for this latest episode. Hey adapters, welcome back. Today our guest is Dr. Sasha Luccioni. Sasha is a researcher working with Yoshia Bengio at the Mila AI Institute to fight climate change using artificial intelligence. She leads projects at the nexus of AI and climate change, using generative networks to visualize the consequences of climate change and tracking the carbon footprint of artificial intelligence. Sasha will discuss the ways AI can be used in both climate mitigation and adaptation. She explains the trade-off between the environmental cost and the benefits of training AI models. Sasha will also share the biggest challenges to be tackled at the nexus of AI and climate change.
Thanks for having me.
Okay, so we've covered artificial intelligence before here on Simpatico, but it's always exciting to dig into machine learning. So maybe to get started, you can give us a little bit of your own background.
So I did my PhD in AI and thought that it would be an interesting experience to go work in different areas. So I started working in, chatbots, and then I spent a bit of time working on Wall Street. And then at a certain point, I realized that the things I really cared about, like the environment and climate change, were kind of orthogonal to what I was doing. And so essentially, I quit my job and decided to go work with Joshua at Mila. And so it was a really major change, but I think it really helped me have peace of mind with regards to the future of our planet. And composting is good, but doing research is better.
So you actually started off originally in artificial intelligence. So can you tell us the area within machine learning that you focus on?
So it was actually the brainchild of Joshua, and he. There's actually this research that was done at some point. People were shown aged version of themselves and asked how much money they wanted to put into their retirement savings. And they found that, one group was shown just current versions of themselves and other people aged versions. And they found that people who showed the future version, the potential future version of themselves, actually saved a lot more money for retirement because it helped them project themselves. And so essentially Joshua was like, well, what if we could do that using AI and climate change? So people have so much trouble acting because climate change, it's obviously having impacts in the here and now, but the biggest impacts are going to be in the future. And so it's making that future more concrete, more visual to people. And so we're using generative networks, so GANs essentially, in order to take an incoming image of a street or a house, whatever someone inputs, and essentially to have do these projections of climate scenarios, either floods, drought, smog, things like that, to tell people, well, these are the multitude of things that can happen if we don't act now.
When I hear about artificial intelligence, it's never quite clear what they mean. Is it just software that you've developed? What exactly is AI in what you're doing?
So the way our model is trained is essentially we showed it a lot of images of just normal houses, normal streets, and then a lot of images of flooding. And it actually learned, so it's actually pretty impressive, that it learned what constitutes a flood, for example. So given a new street that it's never seen before, given a new perspective, it can actually pinpoint the ground. So it's going to figure out where the ground is in the perspective, even if it's diagonal or whatever. And then say the first part of our model says the water should go here. And the second part of our model, it does what's called in-painting. So essentially it looks around, for example, the sky, the color of the buildings, things like that, elements of the scene, and will make the water actually reflect that. So it'll make the water different depending on whether it's, if you see trees around, it's going to have little green reflections, or the houses are brick, et cetera, et cetera. So it's actually pretty impressive because you can imagine, right? It can project things that it's never seen before. And we're currently working to have different levels of flooding and different degrees, things like that. And so I'm actually pretty impressed with what AI can do.
So are you actually in there with the coding? Because a lot of times when software developers are developing things, and I think we've come a long way, but it's all right, we've developed this and it's doing this, but the actual visualizations are quite poor. And how can anyone outside that lab ever use it? Are you part of that process? Or are you sort of saying we do need this to kind of spit out something that's actually usable outside of this lab?
So we developed the machine learning part. It's been almost 2 years. We're actually working on these really powerful algorithms. And now we're working with an agency that's going to help us deploy it. So basically, for example, one issue is scalability, right? Currently, we're running it on our local infrastructure, and we want people to be able to access it from anywhere in real time. So they're helping us scale up. They're helping us make like the website itself, because currently it's just like this crappy little thing where you enter an address and it generates an image. So they're going to make the whole user experience. And it's true that we spent so much time and energy into making this like powerful machine learning algorithm, but now we're facing like a completely new challenge, which is user experience and content, and also like how do you communicate around the images, because we don't want people to think that we're telling them that their house is going to be flooded. No, the idea is like potential scenarios based on extreme weather patterns. So they're helping us frame the whole issue and make sure that it is a tool that hundreds of thousands of people hopefully will be able to use.
All right, so I'm trying to think of the different ways talk about what you're going to do and I guess the applications of it, but then there's this notion of the carbon footprint of AI. Can you talk a little bit about that?
Yeah, actually, so this article came out last year that was pretty impactful in our community of people who do AI and who care about climate change. And essentially, it compared the CO2 generated by a neural network, like a pretty popular architecture, to the equivalent of 5 cars in their lifetime, like including all the gas, like that's used. And so a few of us were like, well, that just seems like a lot. But we realized that there was very little data available. And so essentially the researchers that published that paper, they trained from scratch in their own lab and things like that. And then they measured the CO2. But actually, it's really hard to do that across the board. So we started digging like, Google's new papers, Facebook's papers, do they actually talk about either how much energy they've used or how long they've trained for, or, all these like what infrastructure they used. And most of the time, like all of these criteria were missing. So it was really hard to actually pinpoint and say, well, this model generated this much CO2. And so a few of us, we decided to create a tool. Essentially, the first version was a web version where you would say, okay, I'm training for this long on this type of hardware and also in this location. So we actually pulled like publicly available grid data, and then we crunched the numbers and gave them an estimate saying, well, this is about how much you generated and whether or not it was offset by cloud providers, because some cloud providers do that. And essentially, it was like an idea for people to get at least a global, number of how much CO2 they generated. And now we're working to deploy a Python package that someone can just like load in the background, like while they're running whatever other program they are. Just to load this program that at the end will spit out like a little estimate saying this is how much CO2 you generated, whether you're parsing documents, whether you're training a computer vision algorithm, whether you're just doing software engineering. So any kind of code, it can be wrapped up in this wrapper. And our hope is that people will start using it and start getting an idea of how much CO2 they're generating, and especially we insist a lot about like the factors. So essentially, for example, choosing a greener grid. Like if you're running on the cloud, you don't need to be running wherever you are. You can have the next grid that may be more renewable. And since we have these numbers, we can actually tell people, well, if you had run it in California instead of Texas, then you would have saved this much CO2. I mean, you would not have emitted this much CO2. Or like if you use this much. Like if you distilled your network, because you can actually simplify a network now, if you had a simpler architecture, you would have saved this much. So we're trying to give people like actionable items that they can do, that they can use in order to reduce their carbon footprint.
All right, let me I get that straight though. So when someone's on the computer and you could like wrap up with the software that you've developed, then let's say you're just doing a Microsoft document and you're writing a paper or something. Is that down to that kind of level where it would sort of spit out? And I mean, you're looking at sort of bigger projects and such, how people are going to monitor it.
You could probably do it on a Microsoft, but I mean, the thing is, you would need to put it in the source code. And typically, the thing is, when you're running a program that's already written, especially like a commercial one, you don't access the source code. But typically, if Microsoft wanted to, they could take our package and embed it in the code, or or whoever, like Google Chrome, could have it in the code and say like, this is how much CO2 you've generated by using whatever program. Like, but you actually have to have access to the inner workings of a program. Like, typically, a use case would be like, I'm writing a script myself, and I would it's like essentially like a widget that you put inside your code, and then that didn't just like runs in the background, and then at the end it gives you a little we also did equivalence. So like this was the equivalent of driving 5 miles in a car or 50 miles or things like that. So it's essentially like a little Fitbit for carbon encoding.
Oh, well, that's pretty cool. All right, I want to talk about this paper that you were, and there were like 15 authors, but and you can explain like your role and everything. But it was, climate change and machine learning, and I didn't get a chance to read the whole paper, but I went through quite a bit of it, and it was very exciting. And you make us, there's a series of recommendations, but can you maybe give us a background on what you were trying to say with that paper, and maybe we could dig into that?
Yeah, it was just when I quit my job on Wall Street and joined Mila, there was kind of the group of scientists, group of machine learners that were talking about climate change and who weren't necessarily from a climate change background. Like a lot of them are working on just fundamental machine learning, but kind of like me, they cared about this issue. So including Joshua, including Demis from DeepMind, and so it was basically a way of putting our heads together and giving people ideas, because I think that what really drives research and drives innovation is ideas, right? That's the hardest part, getting an idea, and then the rest of it is just kind of more. It's just kind of the implementation. So we decided that the best way to do this, to inspire people to do AI and climate change research, is to write this paper, and we define like these major sectors like energy, transportation, what have you. And then each person who was responsible for that section met with like 10 to 50 other people who were actually working in this field, and then try to boil it down to between 2 and whatever 5 pages, and to really give like specific problems that could be tackled, like solar forecasting, or helping individual decision making, things like that. So the idea was to like figure out what's being done and then pinpoint specific areas and specific techniques, because most of us, I mean, all of us had an AI background, so we could say like, hey, this problem exists, AI can solve that. And so the idea was really to connect the dots. And I mean, we had a lot of really senior people involved, like Joshua, and they have these really like, so basically he's one of the people who invented this field, right? So they have this broad scope, so you can really say, oh, that specific technique can be used for this problem in whatever wind turbine maintenance that's been kind of a pain point for a really long time. Well, we can use this for it. And so the idea was that it kind of got out of hand. I don't think we were expecting it to be that long, but we kept on finding these new ideas, so we kept building on it and building on it. And then we created this initiative called Climate Change AI, and now we're making tutorials. We're creating a wiki for people to learn, and so we're essentially using the paper as kind of the center of it all, and building upon it, and we have a forum, we have a newsletter, so we're essentially trying to build a community and like an action plan around this.
Now, it sounds like it mainly AI folks who worked on it, but if you look at the different topics in education and finance and infrastructure, lots of opportunities for social scientists to kind of weigh in on what you're doing. Were they part of that process?
Oh, definitely. Yeah. Most of the people we interviewed or consulted were either in policy making, in finance, and things like that. So essentially, what we always, advocate, like I think it's in the first couple of paragraphs of the paper, is don't ever solve a machine learning or an AI problem by yourself. That's not going to work. Like no matter how beautiful the data is, no matter how advanced the model is, figure out a partner in the domain of expertise that you're applying to, and make sure to work with them from square one, from like really from the beginning of figuring out what the problem is, finding the data, clean everything. Just make sure that it's in partnership, and then we keep on coming back to it. But it's kind of in machine learning, they're such powerful tools that people think they can do powerful things with them, which is true. But the whole scoping of the issue needs to really be done with people who know the field, because sometimes you make assumptions as a computer scientist that are not true. And so all through writing the paper and ever since, we've been really trying to bring policymaking and I don't know, like municipal planning, urban planning, and things like that. We're trying to bring it all into the mix and make sure that we're consulting these people.
Well, that's very cool. And I don't know. So the paper's out. I think it's a year old, right?
Yeah.
And the implications of the paper are quite large, and it's almost sort of like a national climate change strategy if you sort of were to take it to that next level. What sort of traction has the paper gotten? I mean, just because when people talk about climate change, they're talking about mitigation, they're talking about adaptation, but here's a sort of a technical approach to dealing with climate change. What's been the response?
So it's been really a lot of people have reached out to us. Governments have reached out. Like some people from Climate Change AI went to COP last year. We had a lot of interest. We've been organizing workshops, and it's really interesting because before, people have been working in this field, maybe like data science or AI, but it's just been very very divided. Like people have been doing it in energy and people have been doing it in transportation. Like this exists. This is not like a blank slate by no means, but we've been bringing them together. So what's interesting is that now at our workshops, we have policy people submitting papers, finance people submitting papers, transportation people submitting papers, and everyone kind of connecting the dots. And there's been a lot of like people just meeting at these kinds of workshops and then going back and then doing projects, which is really kind of cool. And also, I think that we've gotten the ball rolling to make this an actual field, right? Because like recently, I saw a bunch of professorships in Germany at the intersection of climate change and AI. Like this is the first time I've seen like major institutions actually recruiting researchers at this level for this specific topic. So I feel like we're bringing it more into the mainstream discourse around AI and making it like part of the community.
All right, I don't know enough about AI, but I've been exposed somewhat. And if you have a philosophical discussion about AI, and I think the implications of what you're in the paper, like the electrical grid, and well, let's let AI do everything better or smarter, right? I mean, that's sort of the implication. Like it's going to be thinking about ways in different ways. Isn't it sort of an inevitable that machine learning should be a main tool that we use in response to climate change if we really want to do this most efficiently and effectively? I mean, is that in sort of this philosophical discussion? But I guess you're probably having those conversations.
So I think there's different ways of using AI. I mean, a lot of the things that it's been used for so far have been not human facing. So for example, actually Google uses AI in order to optimize their the energy used in their servers, like in their server infrastructure. And that's something that's quite easy. I mean, easy in the sense is it's a circuit. You have like some kind of switches, right? It's pretty it's a closed issue. But whenever you want humans to use AI, really, like for example, to make decisions. So for example, if we want to make smarter cities, right? You can't just create a circuit and have decisions made by an AI how to build a city or how to renovate houses or where to put solar panels. Like you really need to put humans in the loop. And so for me, really the barrier towards a more large scale deployment of machine learning or AI has been explainability. And typically we've been really, really bad at that as a community. Like neural networks, for example, is something that we use a lot, and they're just black boxes. Like you put in a photo and then you get a classification. You put in a word in French, you get a word in English, but you don't know what's going on there. And then what if you say, okay, neural network, why is this a cat? It can't tell you why why it detected a cat in this image, because it's just a composition of weights in an algorithm. And so for me, until we move the needle on explainability and transparency, it's going to be really hard to deploy AI really in the domains that count, in the domains where humans are involved and they need to know things in order to make the right decisions.
Okay, I got some questions coming in from the community room, and Ken asked, "How do you prioritize which types of problems to model and visualize?" And it seems like the options are nearly infinite. And I guess that the papers, in some ways, of trying to put it in a box, and right.
So we had a lot of debate about this. Even in the paper, we identified things as being high potential, high risk, things like that. So, but essentially, the idea is to figure out what are the biggest problems in every subfield. So, for example, energy is kind of the big one. Like, what are people really having trouble with, and then seeing if it's something that AI can help with. So, instead of going from like the methods, because it's true that AI is like a Swiss knife. There's a lot of things you can do with it. We're going really from the domain and like, how can we really help? And then figuring out these connections. So for me, and also, very bluntly, it's also tons of CO2. So something that we think about a lot is, if this were the case, even if it's not a sexy solution, even if it's not something that's particularly like appealing, how many tons of CO2 could we save, right? And even if it's like 2% of the entire transportation industry, that's gigatons. That's huge.
All right, so another question from Ken, and can you drill into how you might collaborate with governments more, and how about utilities?
So the thing is that, yeah, in depending on where you want to work, electricity specifically is managed differently. In some cases, it would be a government managing it. In other cases, it would be private companies. So I think that it's really hard to give a one size fits all solution, but we found that often it's like a win-win strategy. Often, for example, a utility company will have issues, and it's like For example, here in Canada, it's really cold in the winter, obviously, and so there's a lot of heat escaping, and people don't really know that, for example, their windows are badly isolated, and they spend a lot of money on that. Well, so for example, if you can, take satellite images in infrared and then analyze them and automatically send someone saying a bill saying like you're losing this much electricity through your windows, like that's like a win-win kind of thing, because people are saving money and et cetera, et cetera. So it's the matter of like finding solutions and not trying to be like, hey, we're gonna replace all of your grid with solar panels, because like why would they be interested in that, right? It's not it. Maybe they're a hydropower grid. So it's really been about trying to find where it's mutually in everyone's advantage.
All right, and you touched upon this a little bit, but there's some environmental costs associated with AI, and you have to, against the benefits of using it. Could you, elaborate on that?
So this has always been like a big debate as well, because until quite recently, there hasn't been any specific figures. Like, I mean, the best I've seen is that generally information technologies represent 4% of global greenhouse gases. That's like the ballpark figure, but we don't know how much of that AI is. And the thing is that most of it is kind of indirect emissions, because it's like, for example, I'm using Google Maps to get from point A to point B, and in order to optimize my trip, it's going to use a neural network to predict traffic, blah blah blah, right? So but it's not like I don't know that what's going on there, so it's really hard for me to say this is how much CO2 I emitted. So we decided to focus more on like the upstream AI, like the actual training of the AI. So this is something that's tractable, that's concrete. You can actually measure this with like, for example, a package that we made. But there's also the problem of using AI, and because now it's like you've got whatever AI thermostats, you've got Siri, you've got all these kind of connected devices that use AI, and that's really really hard, because typically, for example, the query gets sent to a central server somewhere and then comes back, and that's really hard to measure. So but it's always really interesting for me to compare, at least globally speaking. So for example, nowadays in machine learning, it's always like more data, we want more data, we want more data to solve this problem better. But I've read papers where it's like we trained on, I don't know, say like 500,000 more images, and we got 2% better, or even 0.5% better in this accuracy. And in that case, for me, it's really like, is this trade-off really worth it? Like, you trained on 500,000 images for 2 weeks, for example, around the clock, and then you got 0.5% of accuracy. And that goes back to my point about we need to get a grip. Like, so for example, what if instead of just reporting accuracy, you had to report accuracy and total emissions of your neural network, right? And that was factored into the leaderboards, because there's these leaderboards of like who's got the best AI. And so what if instead of just focusing on like 99% accuracy, we also had that metric? And then how would that shift people's priorities? Because then you would have to optimize, then you would have to reduce CO2 and maximize. Like, basically, AI is all about constraints. You want to have, the fastest decision time while using the most data, for example. But you have to kind of make this trade-off. So essentially, what I'm saying is that environment in climate should be part of this trade-off. We shouldn't be just focusing on accuracy or speed. We should be focusing on planetary consequences, and it can just be a parameter among others. It doesn't have to be more important, but it has to be part of the equation.
All right. So let's say someone's watching this episode and wants to learn more. They represent a local government. And you talked a little bit of how you're trying to make it a more useful tool, but literally, if they wanted to reach out, are you guys kind of there to provide that resource and like, here's the tool and here's how you can use what we're doing? Yeah. How can they do what they're doing better with machine learning based on the work that you're doing?
So we made a website, climatechange.ai, and what we're trying to do is different. So this is something that's also a work in progress. Like, depending on where someone's coming from, information has to be presented differently, and that makes sense, right? So currently, we've got kind of this one size fits all solution, but it's pretty nifty in the sense of you can like look up a domain of application, like for example, yeah, transportation. I'm interested in, or in urban planning, right? And then you can read about like in one or two sentences the different ways that AI can be used. And then if you want to go deeper, you can go and like look at who's working on it. But we have this kind of like top down approach. But what we've been thinking about a lot is trying to put ourselves in people's shoes and say, okay, I'm like a PhD student and I want to find a research project, or I'm a government official and I want to like implement this. And so we're currently working to make the workflow a bit more flexible. And like the Wikipedia that we're making, the wiki is part of that, because we want people to essentially, on one hand, contribute the knowledge that they do have that we don't have, and also to learn about like background information. So we're really working hard in order to make this something that is not just like a 50-page paper that you'll get through or not, but something that's like a living, breathing community of people working together.
But I guess in a perfect world, even partnering with an organization that has staff that's used to doing outreach to the right, even in the urban planning associations, those kind of groups, could really benefit from this tool. And part of it is just getting it into people's hands. And so it sounds like that's your ambition, but that's an expertise that you need to actually do that. So, but
and the issue with AI is that it's still not democratic enough. There's still precious few people who do know how to train an AI algorithm, and that's problematic because ideally, right, if we had hundreds of thousands of people who can do AI, we can just connect the dots. So hey, you want to do AI? Here's a government. Here's a utility, right? And then we can make those connections. But currently, there's a very, very small minority of researchers who are really good at these kinds of approaches, and they're working either for big companies or on these kind of on Wall Street and things like that. And so how do you incentivize those connections to be made, because there's so many of us and there's a lot of people we could help. And so for me, like, making AI more democratic is also one of the pieces of the puzzle.
All right, so we're just at the end of the episode here, and it's been fascinating. And I guess my final question to you is, what's next? What's on your plate over the next 3 to 6 months?
So we're deploying this emissions tracking tool. We've actually partnered up with a platform called Comet ML, and they help people track like different metrics when they're doing AI. So we're adding that as part of the things that they're proposing in their dashboard. We've been partnering up with other institutions, and we're trying to really push for this. And I mean, for me, the holy grail of this would be to actually have people like need to publish this as part of their research, because currently, for example, if you submit a paper to any machine learning conference, you tend to, for example, share your code. So a lot of people already share their code. That's becoming more democratic. But what if you also had to share like information about how long you trained and what infrastructure you used, and eventually the CO2 emissions, and that was part of like the general discourse. Like, so for example, this year, a major AI conference made people add like it's like a societal impact statement. So what is the societal impact of their work? And this was like a big thing because people had to actually think about like whatever algorithm they were optimizing and how it could impact society. And so I want like an environmental impact statement about like to add it to that. So it's like societal and environmental impacts. Like if for example, to train this model from scratch, someone needs to emit 2 tons of carbon, is that really something that should be considered state of the art? So to get this kind of conversation going, so I'm trying to really advocate for that.
All right. Again, this has been awesome. I'd love to have another conversation with you. Maybe there's an area that we could really drill in on, transportation. And so we want Sympatica to be a platform to have these conversations. And I'm going to take you into Just Chatting. And people that are in Just Chatting watching, if you have any additional questions, get those up there in the chat room. And I want to ask Sasha any additional comments that you might have. But Sasha, amazing work that you're doing. And thanks for coming on.
Thank you.
All right. Just hold on. We'll go right into Just Chatting.